Oh, there it goes.
Okay, I'm gonna tell him.
Physics review. Physics review. Okay, so now I will see when our friends are in the
I just told you to
comments
get
over
on.
here. Okay, so we're on projectile motion review. Would you please? I think this thing can probably hear you. That was
On
like a
page
terrible
what?
40. Morgan, would you read and say the answer number 1, please?
Number 1, how does a vector quantity differ from a scalar quantity? A quantity that is completely described by the magnitude only scalar quantity.
So if it's only described by magnitude, then it's a scalar quantity.
Yeah.
Whereas a vector quantity,
A vector quantity
has magnitude and direction. Good. Jada, the second one, please.
Why is speed classified as a scalar quantity and velocity classified as a vector quantity? Speed is at any moment, anytime, and velocity has many variables.
Velocity has just one more variable, which is what?
Velocity has directions.
Direction. Velocity has a direction, right? So whereas speed has just distance and time, velocity also has direction. Hannah.
I believe it's running out of answer. If a vector that is 1 centimeter long represents a velocity of 10 kilometers per kilometers per hour, what velocity does a vector 2 centimeter long drawn to the same scale represent?
I put 20 kilometers per hour.
That's correct. 20 kilometers per hour is correct. Morgan.
Okay, 6. I did 6.
Oh yeah, because it's
Oh yeah, I did that one too.
was it?
Mm-hmm.
It just says 6 through 10.
It says 1 through 6, 7 or 8, and 9.
That's for the plug-in chug.
1 through 3, 6 through 10.
Yeah, so everyone did 6.
Oh yeah, my bad. Okay. Will the horizontal and vertical components of a vector at 45 degrees to a horizontal be larger or smaller than the vector? By how much? I said the vector at 45 degrees. Is that wrong?
Well, it's just asking, will the components of that vector, which is at 45 degrees, be larger or smaller than that vector itself? So it's looking for larger, smaller. Yeah, the legs of a triangle are always shorter than the hypotenuse, and in the same way, the components of a vector are always shorter than the vector itself. Okay,
Yeah, I said larger.
but the correct answer is smaller. That's okay. You see why it is now, though? Because we can represent the vectors as a right triangle, and the components are the legs of the right triangle, and the legs of a right triangle are always shorter than its hypotenuse.
Mm-hmm.
Moving on, number 7.
Why does a bowling ball move without acceleration when it rolls along a bowling alley? I said because its velocity is constant.
Its velocity is constant, which means both its what and what are constant. If
It
its
does not
velocity,
have a
Direction and speed.
its direction and speed are constant, and you're right, Morgan, it does not have an acceleration. Good. Number 8.
In the absence of air resistance, why does the horizontal component of velocity for a projectile remain constant while the vertical component changes?
What do you think? That's okay. What do you think, Morgan?
Is it just asking if it's vertical or horizontal?
No, it's asking how come the vertical component of its. So remember, we're having a thing in projectile motion, so it's at an angle. Why does the vertical component have acceleration where the horizontal component does not have acceleration?
Vertical, most of the time it's accelerating or it's slowing down or accelerating.
Yeah, and both of those are accelerating, right? Slowing down
Yeah.
and speeding up are both acceleration,
And
but
then
yeah.
horizontal is just constant.
Right. And why does it have a
Because
vertical
gravity.
acceleration? Because of gravity. Because it has a force in the vertical direction. So yeah, you're right, Morgan. And then Jada expanded it to be a little more specific, which is that gravity is applying a force, which is making there be an acceleration. Good. So it's really important that you remember from that one that a projectile has 2 components of motion, right? A vertical and a horizontal component. The horizontal component is a constant velocity, and the vertical component is always changing velocity because it always has an acceleration due to gravity. Jada.
How does the downward component of the motion of a projectile compare with the motion of free fall? So the motion of a projectile has air resistance, and free fall has none.
Okay. Yes, on Earth, or since we specifically designed free fall as without air resistance, and since the projectiles we talked about have all been on our surface, that's technically correct. But they are, so there is a slight difference in that capacity. But otherwise, they are what?
Going opposite directions.
Okay, maybe they may have different directions, but otherwise they're the same, right? They're both doing what?
Falling.
They're both accelerating downward due to gravity. So an object in free fall and the
I was
vertical
thinking
component of
of it.
projectile motion.
Projectile.
Right, going up and then down again, but it's still just always accelerating
Two
down.
different objects.
Yep.
I was lost.
Yeah.
10.
It still says the children are not in the chat.
Here, should I see?
Yeah, maybe check it because this says successfully connected, but it says no one's in it.
Physics. Video unavailable.
Yeah.
What? Why? Yeah, it does say I'm the only participant. Well, that is sad. It does say live, but
I will see if it works with my personal.
well, it should.
Not-
It should work even with your school email.
I just told her to try again.
Well, they'll have to watch it later. They will be able to watch it later. They won't be live. That's really annoying.
Working with my phone, with my personal.
Oh yeah, you better turn it off though, because we're gonna get some terrible feedback otherwise. So yeah, that should.
It says 2 people are watching.
Oh, okay. Well then it should be fine. Oh yeah, there it says 2 people over here are watching. 3 now.
Me.
Hannah, participants. Even though when I go to participants, it still just says me. Anyway, we're doing fine. I think they should be. Wow, thank you, Hannah. That's so nice of you. That's so nice. Whose turn is it? Anyway?
Mine.
Let's get back to what's it says here.
I think it's 12.
I think we're on.
No, we're on 10.
I think we're on 10. We haven't done 10 yet.
At the instant a ball is thrown horizontally over a level range, a ball held at the side of the first is released and drops to the ground. If air resistance is neglected, which ball strikes the ground first? So is that like talking about like Haley did?
Yep, that's exactly what Haley did with her
That's
lab.
gonna be the one on the end.
Oh, okay.
Yeah,
Hadley
well,
said
this-
that she's still getting the same thing. So I said maybe she just doesn't have good enough connection.
And that might be true. They should follow the exact same time, right? Because the vertical component of the projectile motion is the same as an object in free fall. Yeah, I know they'll be able to watch this later, so we'll just carry on as if they're able to watch it later. And that's fine. We got it recorded for posterity. So once again, back to number 10. They should both hit the ground at the same time. That is, an object launched horizontally and an object dropped from the exact same height should hit the ground at the same time because they're only accelerating in the vertical direction and not only because of gravity. Morgan.
At what angle should the slingshot be oriented? All right.
Yes.
For maximum latitude,
Or altitude.
altitude, or maximum horizontal.
So the first question is asking, if you want the slingshot pellet to go the highest it possibly can, what angle should you launch it at?
90 degrees.
Yep, straight up. For maximum horizontal range?
45.
45. Good. Any higher than that, and the horizontal component gets less, right? Here's the horizontal component. Woo! It's like a little locker arena. At 45, the horizontal component is at its greatest. If we do it lower, then it's not going to have the height, so it won't stay in the air as long, and therefore it won't go as far. And if we have it higher, even though it'll be in the air longer, its horizontal component is shorter. Jada.
Neglecting air resistance, if you throw a ball straight up with a speed of 20 meters per second, how fast will it be moving when you catch it? Is that 20 meters per second?
Exactly. Yep, it's going to be the same at every height, whether it's on the upward path or the downward path in projectile motion. At every given height, it's going to have the same speed, the same velocity?
No.
No, because it's moving upward when it's going up, it's moving downward when it's going down. It's not the same velocity, but it's the same speed. And that's only if you neglect air resistance.
Neglecting air resistance, if you throw a baseball at 20 meters per second to your friend who is on first base, will the catching speed be greater than, equal to, or less than 20 meters per second? Equal to?
Yep, that's right.
And that does the speed change if air resistance is a factor.
Yeah, and how does it change?
That's all that.
Yeah, it's slower. So in real life, if you throw the baseball at the person on first base, is it going the same speed or slower when it hits them? Slower, but only slightly. The air resistance, especially because it's a ball, doesn't make that much of a difference. And there's a way to calculate it, but it's kind of complicated, and we'll do it later. Morgan.
Okay, 15. What do we call a projectile that continually falls?
Did you have to do 15?
Yeah.
Oh, yeah, I'm sorry. I was looking at the wrong
From
side.
Earth, I said like a satellite.
It is called a satellite. Good, Jacob. Oh, there's Taylor.
17.
Hi, Taylor.
Why is it important that such a satellite be above the Earth's atmosphere? And I said if it is too close, it will fall to Earth. And I can't remember what it said. It's like a burst and fire.
Yeah, because of what? Why
Air
it's
resistance, friction.
yeah, with what?
Heat.
Yeah, friction with what though? You might
Too close to the atmosphere.
yeah, with the atmosphere. Did you say air resistance at first? Okay. Yeah, so friction with the atmosphere is why it start on fire, right? We'd rather not start
I
on
should
fire.
probably say the numbers so they know.
Oh, you're right. I assume that you viewer, it's just Talon. Maybe there's it says 2, so maybe Talon and Haley are watching together and then have
Hadley said okay.
okay. Anyway, so yeah, we should say the number. You're right, Morgan. Thank you. And we're on Hannah, and you're on number 17.
Nope.
Yeah. I know.
Oh yeah, Jada just did that one. So 18. So I should say the number, but I should say the correct one.
Oh, what happened to 15?
We didn't do that. We did, yeah, I did 15, we didn't have to do 16, 17, 18. We're on 18.
We're on 18.
Morgan did 15. We skipped 16. I did 17. Now you're doing 18.
You were answering
Acts on the
15.
side.
Whatever.
We're doing. Go ahead.
What force acts on a satellite that is above the Earth's atmosphere?
I'll give you a hint. There's exactly one.
There's no air resistance.
There's no air resistance. So what one force is acting on? Say it again.
Gravity.
Gravity. Plug and chug.
Can I draw the little picture that Mr. Stelling I drew out,
For number 1.
please? Yeah.
Yep. Go ahead. Go to the board. Can we? Oh wait, you can't. Don't look at it. You can't be on. Go over to the blackboard, please. And we'll show a picture of the. Phew, that was close. Whew, I almost had to work at Wesco.
You would not get fired.
You're probably right, but I don't want to risk it.
Okay, so here's the plane.
Let's look at Jada's though. I'll show you the drawing when she's done, and we're gonna have these little children hide their.
Joe, what's the
Faces.
difference if we know our class?
Yeah.
Well, it's public too, so that like people in the future can watch. I don't want to make it so that
I'll bear the side of paper though.
I forgot
Yeah, I
the
know,
end of a
but-
playlist.
just to
Like
be on.
this.
Yeah, that looks great, Jada. Well, you should be really excited to see this. It's
So
gonna look
it's
fantastic.
moving at 200 kilometers.
Like this kind of paper.
And then tailwind, headwind, power, and tailwind of 75. So that's our little drawing.
Okay.
And then these two.
Why?
So now you're still 120. Because this is pushing against 50 and this is adding 50, and so they just.
Yeah. So elegantly, we could say that they are in what kind of direction?
Inverse.
Or opposite, right? At least maybe inverse, but they're definitely in opposite directions, and so they subtract to 0 since they're the same speed but in different directions. Okay, let's I don't think my computer is portable enough to drag it all the way over there. Plus, if I unplug the mic, it'll be gone forever. So
Where's my pen?
it says calculate the resultant velocity of an airplane that normally flies at 200 kilometers per hour if it encounters a 50-kilometer headwind. If it encounters just the headwind, what's its new velocity?
150.
150 kilometers per hour. If it encounters just the tailwind,
Then it's 2.
then it's 250 because the tailwind means it's coming up from behind. Good. Next question.
Well, whoever has the last one in the answer.
Nice. Lucky you. Number
2.
2. I believe it's your turn, Hannah, whenever you're ready.
Calculate the resultant of the pair of velocities 100 kilometers per hour north and 75 kilometers per hour south.
And what's the answer to that one? Say that first.
Well, the person wrote 25 north.
Yeah, is that right? 25 what north?
I thought it was
Kilometers per hour.
That's
north.
correct. That's correct. And then it says,
once you get out.
175 kilometers.
yeah, but she needs to really read the question first.
Calculate the resultant of both of the velocities.
And then that's the answer. What, Morgan?
175.
Well, almost 175.
Kilometers per hour.
Thank you. 175 kilometers per hour north. Let's have Jada do the next one.
Calculate the magnitude of the resultant of a pair of 100 km per hour velocity vectors that are right angles to each other. Oh, what was it that we did for this one? Right angles to each other. So my answer was 141.4 kilometers per hour.
And the angle? Well, what must it be? If the
45.
yeah, it must be a 45-degree angle. If the vectors are the same, they're both 100 kilometers per hour. There are right angles to each other. That means that the legs of the right triangle we're going to build are the same. So the angle must be the same. And the only angles that can be the same for a right triangle are 45-degree angles. And the hypotenuse has a length of 100 kilometers per hour times the square root of 2, which means it's 141.4 kilometers per hour. We can also figure that out with the Pythagorean theorem, right?
Yeah.
Oh, who's
Stranger joined?
stranger?
Maybe it's.
He's casting magic spells. Let's I don't know what to do.
Shut it down. Shut it down.
Be like, excuse me, sir.
Excuse
this
me,
is
sir.
for